All right, so this system with 3 different masses and the pulleys that are connecting them also have mass, and we are solving for the acceleration of this system. So how do we do this? Well, we set up our 5 equations. So what do we do first? Well, we can start with knowing that this goes down. We can start from the right and go to the left. So the force equals ma. So ma, the mass is 20. Acceleration is unknown, that's our variable, is equal to the force going down counteracted by the force going up. The force going down is for obviously mg, so 20.0 times 9.81 mg minus the force bringing it up, which is our T1. Right, so that's our first equation. Then our second one has to involve the pulley here. So since the pulley has mass, it creates these 2 tensions here. So how do we set this up? Well, we should know that the torque clockwise minus the torque counterclockwise equals to our I alpha. So our I is our rotational inertia, and we are given that it's a thin hoop, and the I is 1/2 mr squared. So our torque clockwise is going to be R, and it is going to be T1 minus R T2, because torque is RF sine theta. The sine 90 is 1, so it's RF, and our F is tension, is equal to our I, which is 1/2 mr squared times rotational acceleration, which is A over R. Now we can we can notice that the R's cancel, so that's a capital R, and this comes out to T1 minus T2 equals 1/2, our M is 10, no R, times the A. So that is our second equation. We start with our 1/2, times 10 times A equals T1 minus T2, right? Our third equation deals with the middle mass, so that is going to be ma, so 6.00 times acceleration of the system equals, well, it's the force this way counteracted by the forces that way, so the force this way is going to be T2, and the forces that way are going to be minus T3 minus, what else is going, if it's going this way, friction is going that way, so our friction, so minus 0.300 mu mgh, or not mgh, mg, mu mg, 6.00 times 9.81. Now we set up our fourth equation, and it's the same concept as this, so it's just going to be our force going that way, RF, the tension that way, minus RF tension that way. So it's going to be T3 minus T4, and we're already canceling out the R's, equals, the solid disk is mr squared, so equals just M, which is given as 5, so M times 5 A. Right? So we can plug that in here. 5.00 times A equals T3, it's an equal sign, minus T4. Right? And then we set up our last equation, which deals with this mass here. So 7.70 times A is equal to our force going that way counteracted by the forces going that way. So all the forces going down this way, left, are going to be our force down ramp and friction. So force going that way is T4, and it is minus by force down ramp and friction. So we can do friction as 0.370 mu mg cos theta. So mu times m, 7.70, times g, 9.81, times cos of 46, the angle, minus our force down ramp, which is mg sine theta, 7.70 times 9.81 times sine 46. Now, what do? Well, you find out that the t's cancel, all of them, negative, 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 boom, boom. All the t's are canceled. Add all these up, and you should come out to an acceleration of 2.27 meters per second squared. But always the possibility of calculating. But that's how you do a question like that.